the most popular algorithm in machine learning that is quite recently popular, but still, it is definitely a very powerful model, especially if you work on large data sets. It will offer you very high performance while being fast to execute. And speaking of performance and execution speed, it is important to remind that XGBoost is the most powerful implementation of gradient boosting in terms of model performance and execution speed. Therefore, it's very important for you to have it in your toolkit. So let's implement XGBoost. This is only going to be an introduction, so we will make a simple implementation of XGBoost, but you will have the code template on your computer and you'll be able to try it on your problems, on your datasets, and you'll see that even with this simple implementation, it will definitely give you some excellent performance. And so now what we're going to do is take one of the business problems we dealt with in this course. This is going to be actually the problem that we solved in the deep learning section. Remember, this is the churn modeling problem, where we need to predict the customers of the bank that will leave the bank. So this was a classification problem where we classify the customers in two classes, those who will leave the bank and those who will not leave the bank. And so remember, for this problem we obtained an accuracy of 86%, but that took quite a while because we trained an artificial neural network with many epochs, and therefore it took quite some time to execute. And so now in this section we're going to do the same. We're going to apply XGBoost on this churn modeling problem. This dataset contains, if I remember, 13 features, but that's not a large dataset. And what is important to highlight is that even if this was a large dataset, a very large dataset, well, XGBoost would be one of the best models in terms of performance, that is, to get a good accuracy and execution speed. So for example, if you are working with a large dataset, I strongly encourage you to test XGBoost. Alright, so what we're going to do now is take the pre-processing phase, so that is only part 1 because part 2 is to implement the artificial neural network, and so we just want to pre-process the data for this churn modeling problem associated to this churn modeling CSV file. But actually we're not going to take everything in this pre-processing phase. The reason is that for the artificial neural network, well, feature scaling was totally compulsory, no questions asked. Feature scaling must be applied for deep learning. But the good news is that for XGBoost, well, since XGBoost is a gradient boosting model with decision trees, well, accordingly, feature scaling is totally unnecessary. And that's one of the very good things about XGBoost besides its high performance and its fast execution speed. It's that you can keep the interpretation of your problem, of your dataset, and of the result you'll get after building the model. So we can understand now why XGBoost is so popular. It's because it has these three qualities. First quality, high performance. Second quality, fast execution speed. And third quality, you can keep all the interpretation of your problem and your model. So definitely a model to have in your toolkit. Alright, so feature scaling is unnecessary here, and therefore we will take everything from here up to the top, like this, copy, and we'll paste that in our XGBoost file. Here we go, and now we can implement XGBoost. So first, let's introduce a new section, fitting XGBoost to the training set. Alright, and first, let's install XGBoost. So, as usual, there's a package, it's the XGBoost package, that will allow us to implement XGBoost very efficiently. So let's type here, as usual, install.packages, and inside the name of the XGBoost package, which is simply XGBoost, like this. So then you select this line and press Command and Control plus Enter to execute, and that's installing the XGBoost package. Alright, we can see it's processing, and here we go. The downloaded binary packages are in this package folder, all good. XGBoost is installed. So let's put that section in comment, there, and now let's import the XGBoost package because indeed we installed it, but if we go down to the bottom, XGBoost is installed but not imported, and we want to make it automatic, so as usual we use the command library and inside XGBoost, and that will import the package. Alright, and now let's implement XGBoost, and actually this is going to take one line, because we're just going to make the classifier, the XGBoost classifier itself. And so basically we just need to create a new variable that we call, as usual, classifier, and then equals, and then we use the XGBoost function from this XGBoost package. So XGBoost and parenthesis, and let's click here, press F1 and get some information about this XGBoost function. So the informations we're interested in are the arguments, and what arguments do we need here? Okay, so first we see that we have this params parameter, which is actually a list of parameters, and these parameters are all the parameters that you can see here. For example, the eta parameter that controls the learning rate, the gamma parameter, which is the minimum loss reduction. Well, you have a lot of these parameters, but this tutorial is just an introduction of XGBoost, so we will not do some tuning on our XGBoost model in this course, but I'm sure in some future courses I will make some more complex implementations of XGBoost on some more complex problems. But in this course, it's just to end with a simple introduction of XGBoost so that you can at least have some knowledge about it and have it in your toolkit. So let's not focus on this now, and let's move on to the compulsory parameters that are, of course, the first one is data. So data is, of course, your training set, the data set on which you want to train your XGBoost model. And so let's input that right now. So first argument, data equals then training set. Here we go. And actually here we only need the features in the training set. So we will remove the dependent variable from this training set because this training set contains both the features and the dependent variable. But what this data parameter expects is only the features. So here we add some brackets and we remove the dependent variable. And what is this index? Well, to do this, we need to import the dataset. But first, before importing the dataset, let's quickly set the right folder as working directory. So right now we're in part 10, then section 49 XGBoost. That's the right folder. Make sure that you have the churn modeling CSV file, and then click on set as working directory here. And here we go. Now we can import the dataset. So let's import it. And that's the dataset. But remember, in this dataset, we don't take all the independent variables, because we're not interested in row number, customer ID, and surname. We know that these three variables have no impact on the dependent variable, so we remove them, and that's what we do in this line. Dataset equals dataset for 14. That means that we take all the variables from the fourth variable of the dataset, that is credit score, up to the last variable exited, the dependent variable. That's the dependent variable. And so let's select this line and execute. And now, if we look at our dataset, well, this contains all the relevant features and the dependent variable exited. And so the challenge is, with all these independent variables here, we want to predict if the customer will leave or stay in the bank. And so that's the dataset we consider to train the model and test its performance. And therefore, the index of the dependent variable we have to remove now in the XGBoost function for the data parameter is the last index here of the exited column. And since we have 11 variables, well, that index is 11. So let's go back to XGBoost and let's go back to our function. And therefore here we have to input minus 11. All right, so we have our whole training set, but without the dependent variable. So that's perfect. That's exactly what we want. So now let's go back to help to see if we need some more info about this first parameter. Well, indeed, there is some very important information that we need to consider here. It's that this input data set needs to be an XGB.D matrix. So that's basically a type of matrix. But we can also see that, in addition, data, the data parameter, also accepts matrix. But this is not a matrix. This is a data frame. So this won't work if we input the features this way. So we can either convert this into an XGB.D matrix or a simple matrix. So let's take the simplest solution. Let's convert this data frame of features into a matrix. And you know how to do this. We just need to use the as.matrix function and put inside some parentheses, because it's a function, this data frame of features. Here we go. And now this becomes a matrix, and that's exactly what we need. All right, perfect. Then next argument. So here again, you have a lot of other arguments, but these are not compulsory, so we won't focus on them now. But the next compulsory argument is this label argument, because indeed here we input the matrix of features, but of course to train a classification model we need not only the matrix of features but also the dependent variable, and that's what we put in this label parameter. And so as you might expect, since we input the features into a matrix, well, we need to input this label parameter as a vector, and to get our dependent variable as a vector, we need to input label equals our training set, then $, and then we take the name of our dependent variable, which is exited, and this will give us a vector. So training set $exited is the dependent variable, but given as a vector. So that's exactly what we need, because indeed, as you can see, label is expected to be a vector, the vector of response values. The response values are, of course, the values of the dependent variable. All right, now, next argument. What is the next argument? Well, there is a third compulsory argument that we need to input here, and that is actually above, but I wanted to put the label after the matrix of features. That made kind of sense. And now there is a third argument that we need to input, which is the n-rounds argument. And the n-rounds argument is the maximum number of iterations. So since we're not working on a too complex problem, well, a maximum number of 10 iterations will be sufficient. So we will input here n-rounds equals 10. And XGBoost will be trained in maximum 10 iterations. Perfect. And now, actually, this line of code is ready to be executed to train the XGBoost classifier. So even if XGBoost is a very advanced machine learning problem, well, thanks to this XGBoost package, you just need this single simple line of code to implement it very efficiently. All right, we're not going to execute this line now because first we need to run the data preprocessing phase, and then I would like to add some code sections to evaluate our XGBoost model performance. So we're going to execute the whole thing in the end, but for now, let's add the last sections to evaluate the XGBoost performance. And of course, we're going to take our k-fold cross-validation technique to evaluate it. And therefore, here I'm going to take the k-fold cross-validation section, which is right here, and we're going to use it on our XGBoost model. So here I just need to copy this section, go back to my XGBoost model and paste it here, and be careful inside of it. We need to change the classifier because right here that's a kernel SVM classifier, and so basically we just need to replace this kernel SVM classifier by our XGBoost classifier. So I'm just copying that here and go back to my k-fold cross-validation section and paste the code to train the XGBoost classifier on the training set right here. All right, and then we need to add another line of code inside this section. It's related to the fact that this XGBoost model will return the predictions as probabilities. You know, it will return the probability of class 1, and therefore, you know this trick, to convert the probabilities into the real predictions 0 or 1, well, we need to add this line of code, ypred equals, and then in parentheses, ypred larger than 0.5, so that if the probability is larger than 0.5, then ypred will be 1, and if the probability is lower than 0.5, then ypred will be 0. So that's why we'll get the binary outcome 0 or 1, and that's exactly what this k-fold cross-validation section expects. And eventually, before we execute the whole thing, there are two things that we still need to change. First, it's the fact that since the training set is expected to be a matrix, well, that's going to be the same for the test set. So here we also need to add as.matrix, and inside of the parenthesis we put our test fold. So that's the first change, and now the second change is of course related to the index of the dependent variable, because 3 here was the index of the dependent variable in our previous problem, where we implemented k-fold cross-validation. So we need to replace this 3 index by the index of the dependent variable in our new problem, which is not 3 but 11, and same right here in the confusion matrix, it is 11. All right, and now everything is ready. We can execute the whole code, so let's do it, and let's see which accuracy we get. So let's go back to the top. We already imported the dataset, so now let's encode the categorical variables as factors. Here we go, done. Now let's split the data set into the training set and the test set. Here we go, done as well. And now let's fit the XGBoost to the training set. So the XGBoost package was already imported. So basically we just need to select this line and execute. Here we go. We get the information of the root mean squared error at each round. So basically the root mean squared error is a relevant computation of the error. You can picture this as the error, and of course, the lower is the error, the better is your model. And we can see that from the first iteration to the last one, the 10th one, well, the error decreased from 0.41 down to 0.29. And besides, we can see that a maximum number of 10 iteration was a good choice because we can see that it is more or less converging around 0.30. Well, feel free to try with more iterations and try to see if it's converging to a number that is less than 30. If you get a number close to 0.30, then 10 iterations was a good choice. So perfect, XGBoost is implemented and trained on the training set. And now let's apply k-fold cross-validation to evaluate its performance with the accuracy metric. And actually I'm noticing that there is still one thing to change. It's the name of the dependent variable here. Congratulations to those of you who noticed that. We need to replace purchased here by the real name of the dependent variable in our problem, which is not purchased, but exited. So let's replace purchase here by exited. And here we go. Now everything should be fine. Let's do one last check. As matrix for the training set, as matrix for the test set. Ypred converted into a binary outcome 0 or 1. Indexes are correct for the dependent variable. Everything looks fine. Let's select this whole section here and get the ultimate accuracy of our XGBoost model. Here we go. All executed properly and very fast, and we get a final accuracy of 88%. So not only that was very efficient, but also we managed to beat the accuracy obtained with ANN. And besides, this value is the relevant accuracy of XGBoost, so we can trust this value of 88%. So that's very good. Not only XGBoost was very fast, but also it gave us an amazing accuracy, probably the best of all the models we implemented in this course. So that was an amazing job. And now it is time to say goodbye, because this was actually the last tutorial of this course. So that's quite a feeling, because this is the end of this machine learning journey that I introduced in my very first tutorial of this course. So yes, that's right, that's the end of the journey. However, I am sure this is not the last machine learning journey. This is your first machine learning journey. I was so happy to take this adventure with you. I really enjoyed that journey. I hope that's the case for you too. And I'll be very happy to make some new machine learning courses to start some new machine learning journeys. So I hope I'll see you very soon. And until then, enjoy machine learning.